All right, so we all know large language models have completely changed the game. They're incredible. But there's this one huge catch. And if you're building anything with AI, you know exactly what I'm talking about. The most powerful models are also incredibly expensive to run. It creates this constant balancing act. How do you deliver amazing, top-tier performance without completely breaking the bank? Well, today we're diving into a research paper that proposes a really brilliant solution.
So here's our game plan. We're going to start by really defining this whole performance versus cost problem. Then, we'll look at why the old ways of solving it just don't work. After that, we'll explore a much smarter approach that actually took its inspiration from a place you might not expect. That'll lead us into the paper's new algorithm, which they call Pilot. We'll see how it performs, and then wrap it all up with what this really means for the future of AI. Okay, let's set the stage. The core issue here is that not all AI tasks are created equal, and neither are the models you use to handle them. You've got this whole spectrum, right, from the small, fast, cheap models all the way up to these massive, state-of-the-art powerhouses. And just throwing the biggest, baddest model at every single user query, well, that's a surefire way to run out of money fast. And that really brings us to the big question at the heart of all this research. Does it have to be a choice? Do you have to pick powerful AI or affordable AI? Is there a way to get the best of both worlds? The goal here is to build a system that's smart enough to make that choice for you, instantly for every single query. And this example from the paper just nails it. It shows exactly why we need what's called dynamic query routing. So imagine a customer service chatbot. A simple question like, what are your business hours? A small, cheap model can handle that perfectly, no problem. But then you get a complex query, like compare these two phones on 3 different features. That requires reasoning, planning, and detail. That's when you need to call in the big guns, the expensive model. A smart router should be able to tell the difference and send the query to the right place. Now you're probably thinking, okay, simple enough. Let's just train an AI to be this router. And that is the totally intuitive first step. But it leads us right into what the researchers call the supervised learning trap. See, this traditional supervised approach, it's just not practical at all. To create your training data, you'd have to take every single user query, send it to all of your available LLMs, and then somehow figure out which one gave the best response. You're paying for every single one of those runs. The cost of doing that at any kind of scale is just enormous. And it's not even adaptable. It's a static system that can't handle new kinds of queries. So to get out of that expensive trap, the researchers looked for inspiration somewhere completely different. A field that's been solving a very similar problem for years, the recommendation engines that power your news feeds. And this is the light bulb moment. Think about it. A news feed doesn't show you every article in the world and ask you to pick the best one. That would be insane. It shows you one article, and it learns from a very simple signal, whether you click on it or not. It learns from limited partial feedback. So what if an LLM router could do the exact same thing? This is called the bandit method, and it's so much more efficient. Instead of needing this perfect best answer label by running all the models, the router just picks one model, gives you the answer, and then learns from a simple thumbs up or thumbs down. And the best part? That feedback mechanism is already built into tons of chatbots today, which makes this super practical to implement. So how did the researchers build this idea into an actual solution? Well, they developed a new algorithm based on this bandit feedback concept, and they called it Pilot. It stands for Preference-prior Informed Linucb for adaptive routing. It's a mouthful, but the idea is brilliant. And for anyone interested in the theory behind it, Pilot frames this whole thing as a contextual bandit problem. It's a classic machine learning setup. Here, the user's query is the context. The different LLMs you can choose from are the arms of the bandit, like the different levers on a slot machine, and the reward is just the quality of the response you get based on that user feedback. The goal is to learn a strategy that gets you the most reward over time. Now, this is where it gets really cool. Pilot basically creates this abstract map, what's called an embedding space, where both the user queries and the different LLMs are all plotted as points. In this space, distance matters. The closer a query's point is to an LLM's point, the better the match. And the whole job of the algorithm is to learn from feedback to constantly adjust this map, pushing queries closer to the models that are actually best for them. And what's really clever is that PLILO doesn't just start from scratch. It has this smart 2-phase training process. First, in an offline phase, it studies a bunch of publicly available data on which model responses humans tend to prefer. That gives it a really strong starting map. Then, once it's deployed, it goes into an online phase, using that live thumbs up, thumbs down feedback to constantly fine-tune and adapt the map in real time.
But wait, there's more. Pilot isn't just about picking the best model. It's also incredibly budget savvy. It has this intelligent cost policy baked right in. It actually frames the budget challenge as a classic optimization puzzle called the knapsack problem. Essentially, this lets it act like a financial planner, smartly allocating its total budget across a whole stream of incoming queries to get the absolute best performance possible without ever going over its limit.
Okay, so that's the theory. A smart, adaptive router that learns from simple feedback and manages a budget. Sounds great, right? But does it actually work? Well, the results from the paper are pretty staggering.
When they tested it on a diverse benchmark with all sorts of tasks, from coding to just chatting, Pilot achieved 93% of the performance of the super powerful and super expensive GPT-4 model. But that's only half the story.
It managed to get that near-peak performance while costing only a quarter, just 25% of what it would take to just run GPT-4 for everything. That's a massive, massive jump in efficiency. And this chart just drives the point home perfectly. It plots performance versus cost for a bunch of different methods. You see that orange line for Pilot? It's consistently hugging that top left corner. That's what you want to see. That's the efficient frontier. It basically means that no matter what your budget is, big or small, Pilot gives you the most bang for your buck, every single time. Okay, let's get a little more academic for a second, but stick with me, this is cool. This chart shows something called cumulative regret. And regret in machine learning is basically the difference between the performance you got and the best possible performance you could have gotten. It's a measure of your mistakes and missed opportunities. So you want a line that's as low and flat as possible. That means the system is learning fast and isn't making many bad choices. And look at Pilot's orange line. It's got the lowest slope by far, which means it learns faster and more efficiently than all the other approaches. It's a quick study. All right, so let's pull all this together. What are the big takeaways from this research? What does it really mean for the future of how we all build and use AI? Look, this is way more than just a theoretical exercise. What this paper gives us is a practical, proven, and incredibly efficient roadmap. It's about moving away from that old, expensive way of training and embracing this new adaptive framework that just gets smarter and smarter with every single user interaction, all while delivering amazing performance on a budget. It's a total game changer. This research makes a really powerful case that the answer to that is a resounding yes. As AI gets more and more woven into everything we do, the need for cost-effective performance is just going to become more and more important. This really points to a future where intelligent, cost-aware routing isn't just some fancy add-on feature, it's a fundamental, absolutely essential part of every single AI system.